Hare Krishna. In this video, we'll be going to discuss question number 27, solution of the IIT JAM 2025 Mathematical Statistics paper. Please pause the video for a few seconds and go through the question. The important concepts that will be required in this sum are maximum likelihood estimator and uniformly minimum variance unbiased estimator. So this is a multinomial distribution that is given. The likelihood function is as given in the question paper. L of p equal to n factorial by y1 factorial y2 factorial into y3 factorial into p to the power y1 into 2p to the power y2 into 1 minus 3p to the power n minus y1 minus y2. And thus we can take the constant out, and thus we can write as proportion, and we get is that p to the power y1 into 2p to the power y2 into 1 minus 3p to the power n minus y1 minus y2, and thus we can simplify it and write 2 to the power y2 into p to the power y1 plus y2 into 1 minus 3p to the power n minus y1 minus y2. We take the logarithm for easy calculation, and thus we get ln of the likelihood equal to constant plus y1 plus y2 into ln of p plus n minus y1 minus y2 into ln of 1 minus 3p. We take the partial derivative with respect to p and we equate it to 0, and we get that this equation we get y1 plus y2 by p equal to 3 into n minus y1 minus y2 divided by 1 minus 3p. When we find out the value of p from this equation, we get the Emily, which is p hat equal to y1 plus y2 by 3n. Now when you take the expectation, it comes to be as p, which eliminates the option A and D. And how p? Expectation of y1 is np and expectation of y2 is 2np, because a multinomial y1 comma y2 jointly following a multinomial distribution. But when you calculate the marginal distribution of y1 and y2, it will come as y1 follows binomial n comma p and y2 follows n comma 2p. You have to remember this. The probability will be 2p, right? So from there we can find out the expectation, and this actually eliminates the options A and D. Next, but we haven't got actually the option which is correct, hence we need to proceed with the other two options. Here, when we arrange the likelihood properly, we can see that this PMF of the multinomial distribution actually belongs to one parameter exponential family, and there is a very good theorem which says that the statistic will be complete and sufficient if that distribution belongs to the one parameter exponential family, and thus this y1 plus y2 is actually the complete sufficient statistic, and expectation of y1 plus y2 by 3n equal to p, that we have already seen, it is unbiased, right? And thus p hat is the UMB of p, and thus option C is correct. I hope this solution is helpful for all of you. Best of luck for the exam, and Hare Krishna.